Welcome to Tech Notice. You thought that choosing a CPU for Premiere Pro is simple, and as I was preparing for this video I realized it's a lot more complicated than I thought. So I have tested so many different CPUs, benchmarking, testing, comparing, doing these results. I'm gonna make it simple for you. Which CPU is best for Premiere Pro? Which CPU should you buy? And how to save money in the process? How does the whole system actually utilize the hardware, not just the CPU? Then you will know which CPU is best for your workflow and which one you should actually be buying. Let's go. It's so annoying. I don't want to pay hundreds of dollars to just change my Windows wallpaper just because my Windows isn't licensed. Well, why don't you try Hookeys? That's a ton cheaper, and if you use the code TN20 you get it even cheaper. What do you mean? How do I get it and how is it possible? Well, see this video here, or the one you're watching. Click in the link on the video description, add the Windows 11 CD product to the cart, proceed to checkout, add the code TN20 for the extra discount. So what, the Windows 11 Pro OEM key is just $23.22? Yeah. Choose the preferred payment option and complete the purchase. The key will be available on the purchased orders in a few moments. Copy the key and paste it into your Windows activation settings, and you're all done. Well, that was easy. Is that Ryan Gosling? No. Anyway, by the way, the same discount code also works website-wide, so go check out other products, maybe like Microsoft Office. Hit that like button, subscribe if you haven't already, and if you want to reach out to me, I'll always get back to Minect messages within 24 hours. Links for those in the description below, as well as your favorite CPUs if you want to check the latest pricing and Testbench setup. The links are in the description below. They're affiliate links, which gives me a small commission at no extra cost to you, so consider that when buying. I'm going to start this with actually talking about the codecs that Premiere Pro utilizes, and this is where things get very, very confusing. You think that just one CPU is best for all the stuff for video editing in Premiere Pro, but actually that's not the case at all. Codecs are the ones that make the biggest difference. In large scale, there are 3 different types of codecs, and I'd like to explain this to you so you would know what you are using in your workflow and how does that affect the hardware, because the CPUs kind of play and act differently depending on the codec you're using. Firstly, I want to talk about Intraframe codecs, and they're the codecs like DNX, ProRes, and if you're using mirrorless camera, they can be named differently. For Sony, for example, it's called XAVC-SI, and that I means Intraframe. And then Canon, Lumix, they might have slightly different naming for this, but Intraframe codec means that it's a video and each frame is separately recorded. This is what you thought video is like. It's basically just taking JPEGs, except lower quality, each frame 24 frames per second, and then when you play back, you're playing back each frame. You pause it, you just process the frame, and then you keep going. It's very, very straightforward. Now, the benefit of Intraframe is that it's a bit easier to work with LongGOP, which we'll get to in a minute, but the file sizes are big because it has to store each frame separately. It captures the frame, captures the frame, captures the frame. Never mind what happens in the frames, every single frame is recorded separately, so the file sizes are a little bit larger than LongGOP. And it's also easier to play back with because we can play back each frame separately and it doesn't need to look at other frames when playing it back. It's quite a straightforward process, so it's easier on your hardware. Secondly, the most popular codec what you will see out there is the LongGOP codecs. This means long group of pictures. Now imagine the same frames, but the codec stores them differently. It looks at each single frame and then looks what moves in the frame. Let's say you have a shot of this, what you see right now. All the background, nothing changes in there unless I put my hands down there. And that means that instead of storing all of the pixel data all around me and in front of me, it knows that that doesn't change between these frames. So why don't we just store it in the first frame, but delete it from the other frames? But then store all the other data that gets moved within the frames. So the actual picture gets stored long group of pictures. So in order to figure out the frame kind of in the middle, it has to look at some frames before and after to figure out what that frame is. So the benefit of that is that the file sizes are a lot smaller. it's compressed because it looks at the frames differently, just like that. The downside for that is that it's very hard to play back, because whenever you pause the video and press play or go back, the hardware has to look at not just one picture to actually give you a picture on the screen. It has to look at some of these before and after to figure out what that is in there. That's called decoding, or playing back the footage. So when you're on your timeline working with the video, the decoding of long group of pictures is very, very demanding on your hardware. Long group of picture codecs are the likes of H.264 and 5 or AV1. There are different wrappers for the codec. So for example, when you're looking on your Sony camera, it doesn't tell you that it's a H.264 or 5 codec. You might be looking at XAVC-S, XAVC-HS, something like that. So this is basically a wrapper for the codec. Once you play that in your computer and go properties, you can see whether it's H.264 or 5. AV1 is another one of those codecs. It's even more compressed and even more efficiency in terms of file sizes, can be even harder to play back, if that makes sense. But at the same time, there are specific hardware built in either CPUs or GPUs, media engines, that can play back the long group of pictures very, very easily. Sometimes even easier than the Intraframe codecs, just because you've got dedicated hardware that just knows how to solve that algorithm or that just equation very, very fast. So we'll talk about that in a minute. And then thirdly, there are raw video codecs. And the raw video codecs, imagine them as Intraframe. So all these pictures that have been recorded separately, but instead of it being a still image, like a JPEG on photography, it's a raw photo. So it stores raw, and every single frame is separately. Whenever you pause it, it just can play back there, but it is raw. So that means that now the file sizes are extremely, extremely large. But at the same time, it can be quite easy to work with. But there's a huge but. Depends also on the resolution, because the file sizes are so large and it plays back such a lot of data, it does require a little bit more resources to actually just crunch through that data. So if you've got large resolutions of data, then having a large core count CPU will actually be better for you, because it can actually play that back. SSD speeds might actually come to play for you as well if you've got a very high bitrate raw codecs, because it has to read them from the SSD. And if you've got a SATA SSD, but you've recorded it at like 1,000, 2,000, or maybe 2 gigabytes per second bitrate, or gigabits per second perhaps, then your SSD might be the bottleneck. So we'll talk about that in a minute. Now, remember those 3 types of codecs, because you will be working with one of these codecs, and depending on your hardware, you might choose one that works best for your specific workflow. And sometimes within your workflow, you are utilizing different types of codecs. You might be recording LongGOP, then you convert it over to Intraframe, and then you export it to LongGOP again because you publish it on YouTube or somewhere else. Or you shoot RAW, and then you convert it to Intraframe or LongGOP, and then you export it to LongGOP. So depending which stage your workflow you're in, you might use different codecs, and depending where you spend the most time, certain hardware might work best for you. Does that make sense? Next, I want to talk about the biggest kind of bad, false, wrong information out there, what I see a lot of big channels make. And they are just using this as normal because they're so used to doing gaming benchmarks, yet for creators, it's a lot different. So the number one biggest mistake that I see people make out there is that they don't enable iGPU. Enabling the iGPU, the tiny little graphics processor that's inside your CPU that already comes with a lot of the Intel CPUs and now also AMD Ryzen CPUs, that can enable you to have a lot faster performance with certain codecs. Like Intraframe and LongGOP, Intel iGPU can just give you a lot of hardware acceleration. So you shoot with your Sony camera, you shoot 10-bit 422 H.265. Now playing this back on AMD or Threadripper is like a slideshow in Pro Presenter or PowerPoint using Intel iGPU, the tiny little one, never mind what dedicated GPU you have. In Premiere Pro, the playback is buttery smooth as if you've got, I don't know, 720p footage and you're working with it. It's so easy. So sometimes the resolution is not the issue, it's the actual hardware that can play this back. Not every single codec is hardware accelerated, but the certain very hard ones to work with, Intel iGPU gives a big boost in that. So when you look at some of these benchmarks out there by other big names, you see that AMD CPUs perform a lot better, and that's because they've left the iGPU off on Intel CPUs. If you enabled it, you just get kind of extra performance, and that's what you're going to see here in a minute. Unfortunately, the iGPU that AMD has inside their CPUs is kind of useless. Threadrippers don't have any GPU, but the AMD one is kind of useless. Now, the iGPU thing and having hardware in there, in a minute you'll see there's something that completely flips it all in the head. I'll explain that in a minute. But secondly, the biggest mistake is that if they don't tell you which GPU they're using to test these, often they go with NVIDIA GPUs, but right now, the 4000 and 5000 GPUs, there can be a huge difference. And also, depending on the 4000 or 5000 NVIDIA GPUs you're using, you can also massively either make Intel iGPU useless and take the advantage of Intel and give it to AMD, or put them kind of in the same ballpark, or give Intel massive boost by not using 5000 series GPUs. So what I'm talking about here is that with the RTX 5000 GPUs, now NVIDIA released the new media engines that are on every single 5000 series GPUs, and the higher you go, the more you get the media engines, the better your video editing performance will be, and the best one is RTX 5090. And now the 5000 series NVIDIA GPUs allow even more codec playback than Intel allows or has built into their iGPUs with their latest Core Ultra or previous generation CPUs. That now gives a very fair advantage to AMD and Intel if you are using a 5000 series GPUs. Now, they're not very widely available yet, and people are still implementing them into workflow, and the workflow is kind of temperamental because not all applications offer fully version of this. Even Premiere Pro here, what I'm testing you here, won't give you the full, at the time of me making this video, there isn't a full public version of this software that allows you hardware acceleration on the 5000 series NVIDIA GPUs. It is available on beta, but not the non-beta version. Now, that being said, let's look at Premiere Pro as the software. Which hardware is actually the best for your workflow, which is the most important in order of hierarchy? Number one, the CPU, and that's why we're looking at the CPU first. CPU will give you the most performance there. You can have a bad GPU or a little bit of other things, bottleneck somewhere else, but the CPU will give you the most performance. At the same time, it depends which codec you're using and if you've got iGPU enabled or not. So whenever you're buying Intel CPUs, make sure that you do buy the one that has iGPU, not the one that doesn't, unless you're using Intel Arc. Second most important hardware is the GPU, because depending on what GPU you go for, it also gives you a lot of VRAM. So if you've got higher codecs and you're playing back with high resolution codecs, you need more VRAM, and also hardware acceleration now on the 5000 series. So that can give you a huge boost in performance. Thirdly, RAM. Premiere Pro loves to use a lot of RAM, and I highly recommend getting 64 gigabytes unless you're using higher than 4K resolution, then get 128 gigabytes because it loves to use a lot. We are using multicam of 4K and 6K timelines. We can easily use over 64 gigabytes just for a reference what you might be needing for your workflow. If you think 32 gigabytes is fine, it's fine for very basic things, but I'd highly recommend going 64 gigabytes because Premiere Pro loves to use a lot of RAM. And number four is the SSD. Depending which codecs you're using, like I mentioned, if you've got high bitrate raw codecs that you've recorded and they're large file sizes, you might want to go for a very fast SSD as well, just because you're reading back a lot of data and you don't want the actual SSD to be the bottleneck in there for your software. Bear that in mind. Now, when we're looking at the standard overall scores, what you can see here is that on the top, we've got Intel CPUs, and they're performing the top of the chart for standard. The first AMD CPU is the 9950X in the prosumer platform. We've got the Threadripper, which is so expensive. The orange one is kind of like a Threadripper benchmark, so you can actually kind of have an idea where the Threadripper will line up. That is a $10,000 CPU, so not for everybody, but just so you know where that would kind of line up in there. Very importantly, if you want to check out the Testbench setup of all of these platforms, I'm testing them slightly differently than most of the platforms or media outlets out there. Firstly, I'm using RTX 4090, which means we don't get the extra boost for the 5000 series. Secondly, I've got iGPU enabled. And thirdly, I'm using the stock setting for IMC. So whatever the memory profile is, I'm using that setting rather than matching all of these, because some of these might not be as stable and some of them might have to downgrade or upgrade. So I'm using whatever is the stock IMC setting for each of the CPUs. Now, very importantly, if you're wondering like how much better or worse this is, then the 9950X is roughly about 9% slower than the top of the line 265K. Interestingly, for some reason, the Ultra 7 for me performs the same as the 2 Ultra 9. So if you're wondering if you're getting any performance boost in there, I highly recommend going with Ultra 7 because apparently it's very, very good. Now, you might be seeing that there's 2 Ultra 9s in there and then in there. It's because Intel has also released the boost profile now, and I wanted to test what the difference in there is. So without the boost, so this in here is extreme profile, and then the boost profile is there. Boost profile should be higher than the extreme one, but just so you know, you can see boost and 8000 megahertz because the actual RAM configuration also improved. Now, interestingly, whether you go with the X3D or non-X3D in here, there is really no difference in there, and you can see that for creators, going with the 3D doesn't really make a difference, so you can save some money and go with that one. At the same time, we've got something in here which is Core Ultra 5 235. That is extremely, extremely cheap CPU in there, and it performs kind of couple of percent of the high end of AMD Ryzen CPUs, which is very, very interesting mark in there. So if you want to save some money, going with that one is absolutely amazing. As you can see, I don't have the 245K in here because I need to retest it and add it in here again. If you haven't seen the review of the 235, go check that one out. Also very, very efficient in power efficiency. So definitely one of those things to kind of look out for. Interestingly, the 8-core AMD CPUs are on the bottom part here. Call this as the lower tier. Whether you've gone with the 8-core or even the 12-core here, this one, that is on the bottom of here, and Intel 13600K performs a little bit better, the 14600K. But this section here, they're kind of just all within margin of error, as you can see on this side. But this is the standard overall score, so we're not going really in depth in certain things. And if you're wondering how certain CPU performs, I highly recommend going checking out my live streams. So type in like Tech Notice, 9995WX live stream or something like that, because recently we did a live stream where we tested the 2 RTX 5090s and it was unbelievable performance. Now moving on to extended overall scores, and we've seen a little bit of a better kind of stretch of the CPUs. We still see that Intel is on top of the charts, and now here with the extended overall scores, going with the 285K or Ultra 9 does make a difference with its boost profile. It gives you a little bit of extra score, so you can see that if you're doing a little bit more heavier video editing, it is worth it there. The Threadripper, again, kind of just under the Intel there, but you can see that having so many different cores doesn't really make the CPU that much better. It kind of just brute forces its performance through of whichever codec you're using. The 13th and 14th gen i7s and i9s are here. That is weird, i9. Right there on top of the chart. And then the first one here with the Ryzen 9 95WX, as you can see these bits here. Interestingly, in extended scores, we're roughly about 14 to 15% slower compared to the Ultra one there. So there is a little bit of a bigger difference in overall scores. Then interestingly, the middle pack is kind of, again, populated with Intel CPUs. The 16-core AMD is here a little bit higher than the rest of them. But interestingly, if you look at these two in here, then that is 13600K i5, very, very cheap. And then the high-end previous generation AMD 7950X, which is very, very interesting in extended scores, how you can save a lot by going with Intel just because Premiere Pro loves Intel a little bit more. It's a little bit of a shame that AMD's CPUs don't really work as well in there, but at the same time, if you go with 50 series GPUs, it might be slightly different. Extended LongGOP, so now we're working with HS264 and 5 codecs and ProRes and so on. You can see that the top part is basically just populated by Intel. And then the bottom one is AMD, apart from Threadripper, because the Threadripper more cores, it just brute forces it through, which is insane. There is a weird thing happening here that I also want to mention, which is about the Intel Core Ultra 9 285K boost and then the new one. For some reason, I don't know what happens, and I'm using the latest drivers with the boost profile. And actually, whenever testing this again, I don't know why, but the LongGOP score is a lot lower. I think this is some kind of a mistake in the system because you can't just reduce the performance unless the boost profile really reduces this in there. But it doesn't make sense because you would have just hardware acceleration on the actual iGPU in there, and that should be playing this back. But this should be actually up there and on top of it, and I don't know why it isn't. It kind of doesn't make any sense, but I just want to point that out. So interestingly, even the Ultra 5 235 is faster than the 9950X of AMD, and the price difference here is absolutely ridiculous. So this is one of the things that you don't see anywhere else online, and you usually see that AMD CPUs are up there, but actually in real world, if you enable iGPU, you'll see that Intel will be a little bit better with the LongGOP compared to AMD. And when I saw some of these scores online, I was like, I don't know what they're doing, and that's why you're in here. Now, looking at extended Intraframe score, remember what Intraframe codecs are, and here we can see that having the Intel Core Ultra and Boost, you are really putting it to a whole nother level in here that is quite a bit faster than the rest of the things. There is roughly about 11% boost compared to the Threadripper going to the Core Ultra 9 285K. That's huge performance difference. Now, the 9950X here is not something to be taken lightly of. It's right up there with anything else, but at the same time, the Core Ultra 7 265K is very, very impressive, performs better, and now is even more reduced in price. How do I know that? Because Intel sponsored some of the other things on the channel where I didn't even know that, but the 265K has been reduced in price, so highly recommend checking that out in the video description below, because that for Premiere Pro workflow just works a lot better than the 9950X. Now, then we have the kind of i9s and Ultra 9s from previous generation of Intel here, and then the rest of the pack comes down here. Interestingly, I'm kind of disappointed at this CPU here, the 12-core Ryzen 9, because I want this to perform a lot faster than the rest of the things. I think it would be a good middle ground CPU for most of the high-end, because it's Ryzen 9, but not the 16-core, but the 12-core. I would love this to perform a little bit better. The Intraframe here, if you're doing a lot of Intraframe, interestingly, the Ultra 5 235 isn't that good anymore. It is just down there and kind of in the bottom back with 14600K and so on. But interestingly, it's still quite a bit faster than the 12900K, what you see in here, 14600K, and still is much more affordable. Now, if you do want the gaming CPUs, you've got the X3D in there and then in there, but they don't perform necessarily the best in this particular Intraframe codec scenario. Now, finally, we're looking at the raw scores, and here we see that Intel is performing the best. At the same time, I want to give a little asterisk in here because I think the Threadripper in terms of working with RAW is the absolute best CPU to get. Because whenever we did the live test of using Canon RAW 8K or 8K Red RAW, we used 5090s, we used two 5090s, but in there the Threadripper was unbelievable. And I've never experienced anything like that. So I think if you're doing, let's say 6K and above RAW, maybe consider also Threadripper. If you're doing 8K and RAW, 64K or Threadripper, and you're probably going to be a studio then at that point, you'll be working with Arri RAW, Sony RAW, whichever other RAWs, you know, massive RAW files, Canon RAW, so on, then you'd probably want a Threadripper just to crunch through. Unless you're using, you know, transcoding this into lower resolution or LongGOP or Intraframe or something like that, then it might be obviously easier to work with. But interestingly, the Ultra 7s and Ultra 9s here, there is quite a big gap from here to here, as you can see, which is interesting. So previous generation of Intel and now the new generation with the boost profile and everything in there really shows a difference. Interestingly, the boost doesn't actually give us that much of difference compared to the non-boost profile in the raw scores, which is kind of the same in here, but within margin of error, but the average of multiple tests does perform lower than that. Interestingly here now, the X3D is faster than the non-3D version of AMD Ryzen. So that's another interesting thing up there. So sorry about that. Previously, this was actually blue as well. So I just changed it to just so you know where the AMD CPUs are there. Interestingly, this kind of bottom pack, this part here, they all perform within margin of error of each other. So 7950X and then the Core Ultra 5 235. Interestingly, in raw scores, it wouldn't make really sense. And I don't know how this is possible, but apparently it is. Encoding and decoding, they perform very, very similar. And even the high-end AMD CPUs here perform the same as like the 13600K in here. Just bear that in mind when thinking about the CPUs. Interestingly, I'm a little bit, again, disappointed that this performs so much lower than that. And then obviously the 8-core CPUs on the very low here, they're not performing that well. And then finally, what we have here is the GPU FX. And this is not necessarily important here because if your CPU, let's say, is lower, then you're kind of bottlenecking the GPU. So you're testing if your CPU is a bottleneck for some other bit in your hardware. But basically, the Intel parts are there on the top, very, very much the same. Between the Threadripper, so this is minus 10% in here. And then at this point here, the 9950X is minus 16%. So as you can see, this part here, they're kind of all very, very much the same. And they perform very much the same in this area. So these types of CPUs. So GPU effects, really, there's like the top end, bottom end, and then large middle class in there. Doesn't really make that much of a difference, but seems like the faster the single core is, as you can see on the top part there, then the faster your GPU effects will be as well. But honestly, I wouldn't consider this a very much like a real workflow scenario for your workflow, because they're testing like ridiculous amount of lumetri colors and other GPU effects on top of each other to actually show you the difference. In your just a couple of, you know, lumetri colors and curves and other things that are GPU accelerated, they don't really matter in this case. Which one is the best bang for buck and which one should you be actually getting? Here's the thing, I highly recommend checking out the latest pricing in the video description below, but not just the CPU pricing, but check out the platform cost. If you're thinking, oh, I think for my workflow, this AMD CPU works really well, or this Intel CPU works really well, have a look at also the motherboard cost. Because what I have seen recently, because of tariffs and everything, the prices have gone like kind of all over the place again. The 13th and 14th gen that are previously massively recommended for video editing for Intel, because they were just so affordable. Now, even though the CPUs are cheap, because a lot of the CPUs can be manufactured also in the US, if I'm not mistaken. But then at the same time, the motherboards are manufactured in the US, so the motherboards are so expensive. And what I found is that the Core Ultra series, so Z890 or B860 motherboards, are actually a lot more affordable on the Core Ultra, which kind of makes me tell you that don't go with the Intel platform on the previous generation, but Core Ultra, because it's just cheaper and later and gives you more future-proof and upgrades and so on. And at the same time with AMD, AMD's, interestingly, you can buy a previous generation motherboards like the X670, but sometimes the previous generation you think, oh, I'm going to get a better deal, I'll go with that one because there's not big difference between X670 versus X870, but then the price difference of X870 is a lot cheaper than the X670. So whenever you're choosing the platform, please check out the platform cost and the motherboards, because you might actually save yourself a lot more money by going with that rather than a different one. I hope that makes sense. If you found this helpful, hit that like button, subscribe if you haven't already. Again, PC build guides in the video description below if you want to build anything for yourself, and reaching out in Minect if you require any support for your specific workflow or want to reach out and get yourself a ridiculous PC build. I'll always get back to Minect messages. Thanks very much, guys, for watching. God bless. Bye-bye.